Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni. Today we are going to solve our next quiz. This quiz will contain 8 questions from random chapters and subjects. I hope you are able to answer all the questions. So let's start with question number 1. If the exhaust valve of the piston engine is closed and the intake valve is closing, then the piston will be in what stroke? So we have 4 strokes for piston engine, right? We have 4 strokes for piston engine: intake stroke followed by compression, then power, and then exhaust. So during the intake stroke, we have intake valve open and we have exhaust valve closed. So this cannot be the option because in the question it stated that your intake valve is just closing. That means it should not be open. Okay, and your exhaust valve is closed. Next thing, so this is not the case. In your compression stroke, both your valves, intake as well as exhaust, is closed. So both are already closed. That means exhaust valve is closed and intake valve is closing. That is not the case here. So both are already closed. So compression stroke will not be the answer. During your power stroke, again both your valves, intake as well as exhaust, remain closed. So both closed. The last thing, the exhaust valve. In this case, what happens? Question 1. If the exhaust valve of the piston engine is closed and the intake valve is just closing, what piston stroke will be in? Now in intake valve, your intake valve is open and your exhaust valve is closed. That means your intake valve is not closing. So this option will be wrong. Now let's take the next stroke, compression stroke. In the compression stroke, what happens? Your intake valve, which was open in the intake stroke, will now will now start closing. And the exhaust valve, what will happen to exhaust valve? It was already closed, so it will remain closed. Okay, so exhaust is closed, intake is closing. Because now the fuel air mixture is already there, so intake valve will close. Okay, after fuel air mixture enters the engine. So this can be the option. This is the right option actually. Let's check power stroke. Now in power stroke, both valves will remain closed. Intake and exhaust valves will remain closed. In exhaust stroke, last stroke which is exhaust stroke, in this stroke, your intake valve will remain closed and your exhaust valve will open. Exhaust valve will open so that all exhaust gases of fuel air mixture will go outside into the atmosphere. So this cannot be the case. This also cannot be the case. So the compression stroke is the right answer because after fuel air mixture enters through the intake valve in the engine, the intake valve will close. Exhaust valve is already closed from the intake stroke. Now both valves close, compression stroke. The piston engine will move from the bottom to the top of the cylinder to compress that fuel air mixture. So correct option is option number Bravo. Okay, compression stroke. Next, on what principle is VSI based? Vertical speed indicator. So vertical speed indicator is based on the principle of change in barometric pressure. Eco reflection is primary radar, and static and dynamic. Okay, static and dynamic is irrelevant. Actually, airspeed indicator is that instrument in which dynamic pressure comes. An airspeed indicator works on the principle of total pressure minus static pressure equals to dynamic pressure. So option C is irrelevant in this case, and even in the case of ASI. Now this is how your VSI indicator looks. Okay. So above the now currently the VSI is showing 0 feet per minute, means flight is straight and level. If the arrow goes up, that means above 0 there is a rate of climb. Okay. Above 0 you will be registering rate of climb. Any value below 0 will be rate of descent. Okay. So that is your VSI ka basics. So 5 means 500 feet per minute, 1000, 1500. Same rate of descent 500 feet per minute, rate of descent 1000 feet per minute, rate of descent 1500 feet per minute, so on and so forth. Now this is the back side of your VSI. Now in VSI we have static pressure going into your aneroid capsule directly. Okay, going into your aneroid capsule directly. And then we have also static pressure going inside the instrument, this instrument case, okay, which is surrounding this aneroid capsule. We also have entry of static pressure there, but this entry of static pressure will be at a reduced rate, so all the outside pressure from the atmosphere will enter this capsule of aneroid directly, non-stop. This input will be there, but in the instrument it will be fed at a reduced rate or a calibrated rate. Okay, through this calibrated leak. Through this calibrated leak, it will enter the instrument at a reduced rate compared to the rate at which the aneroid capsule is getting the static pressure. So finally, there is a comparison made between the rate at which the instrument is getting static pressure and the rate at which this aneroid capsules are getting static pressure. Now, as aeroplane climbs or descends, okay, different levels, the static pressure going into the aneroid capsule will be different. If it climbs, the aneroid capsule will get less and less static pressure. If aircraft descends, it will get more and more pressure, right? So that pressure directly will be felt by the aneroid capsule. But in case of this calibrated leak, at which pressure is released at calibrated rate in the instrument, that will be constant. So the only way that we can determine the VSI rate, how fast we are climbing or how fast we are descending, depends on the barometric pressure or static pressure going in the aneroid capsule. Okay, that pressure will be compared with the pressure at which calibrated leak releases calibrated pressure in the instrument. Okay, so if it happens fast, if the difference between them is big, that means the rate of climb is happening very fast. If the difference between them is less, a little, the rate of climb or rate of descent is shallow or very slow. So there I will do a detailed lecture on VSI. And I will upload that video in the instruments playlist of navigation. There you will find this VSI detailed video, and also we will solve questions from Oxford, Keith and Williams from VSI, and I will upload the respective videos in the respective playlist. So you can find it there. So as of now, just remember that VSI is based on the principle of static pressure, change in barometric pressure in the capsule, in the aneroid capsule. Next, AAL, alpha alpha lima, means what? It means above aerodrome level. Above aerodrome level. Okay. Above aerodrome level means above the airport, above the aerodrome. Next question. The pressure distribution at place B. What is it called? Now look here. At A, at location A, we have pressure of 1020. Then the pressure is decreasing as we go outside. 1015, 1010, 1000, and then 995. So when you compare the pressure at A and pressure at B, you know pressure at A is high pressure pressure at Bravo compared to A is low pressure, right? And at A it is high pressure. Now the pressure at B is what we have to find. Now by definition, the pressure falling between a high pressure and low pressure is called COL. Okay, the pressure falling between high pressure region and low pressure region is called COL. So correctly, so according to that, answer to question number 4 is alpha COL. Next thing, question number 5. The altimeter is connected to what? Elevator. Elevator is a control surface. Pitot tube. No, altimeter is not connected to pitot tube. ASI, airspeed indicator is connected to it. Dynamic system, there is no such system. We have dynamic pressure that we get from pitot pressure. Static system is the correct system. Now we have three pressure instruments: altimeter, PSI, and airspeed indicator. Out of these three, all three are connected to static port. All three are connected to static port. So we will draw one static line. All three are connected to static port. Okay. And then airspeed indicator is the only instrument which is connected to a pitot tube, which is connected to a pitot which is connected to a pitot. Okay. And therefore the pitot pressure will only be delivered to airspeed indicator. The pitot pressure will only be delivered to airspeed indicator. So this is the final diagram. Okay, so this is a static pressure system. Static port, and we get static pressure delivered to all three pressure instruments. Pitot tube, only one instrument, airspeed indicator. So altimeter is connected to static system directly, not the pitot system. Question number 6. How long will a TCAS 1 give a warning for? Now TCAS is traffic collision avoidance system. Okay, it's a traffic collision avoidance system. Now let's say this is your aircraft. Okay, traffic collision avoidance system is based on secondary surveillance radar principle. Okay, now if you are flying in a particular airspace, you will be surrounded by so many aeroplanes, by too much traffic because of today's scenario. Okay, and it is of vital importance for aviation safety that you keep getting updates about traffic around you. This information is provided to you by ATC directly, and also to enhance safety we have in-flight equipment. Okay, we have in-flight equipment which is based on radio navigation, that is transponder, and TCAS, traffic collision avoidance system. So as soon as any other aircraft, okay, or any other traffic comes closer to you, and and within a range of particular altitude with respect to your aircraft, your system, that is the traffic collision avoidance system, will give you that traffic information, such as so and so traffic or so and so aircraft is at so and so far away from you, or so and so height with respect to your height. Okay, so this traffic information is provided to you. So this is the work of TCAS 1, which is traffic collision avoidance system. So there may be too many aircraft surrounding your particular aircraft. So we always need protection from them. So traffic collision avoidance system, it works on the principle of radio, secondary surveillance radio. Okay, radio principle. It requires transponder in your aircraft and transponder in both aircraft, that is yours and the traffic. Okay, it requires that. So this is the case how it operates. So we have two types of TCAS. TCAS 1 and TCAS 2. Okay, so first there was TCAS 1 and from there we developed TCAS 2. So I will just take another slide. Okay, now this is your aircraft. Okay, and we have to draw two bubbles surrounding your aircraft. The outer bubble I am giving a yellow color for easy distinction. And the inner circle I am giving reddish color, dark red. Now, when there is a traffic, any traffic which is in the outer bubble, okay, we call that bubble as caution area. We call it caution area. Okay, it is at a distance of from the aeroplane 30 to 40 seconds, approximately 30 to 40 seconds. So when the other traffic or when other aircraft is at a distance of 30 seconds to 40 seconds away from you, it will be the caution area. And when that traffic is in a caution area, the TCAS equipment will give you traffic advisory. It will issue you traffic advisory. Now what is traffic advisory? Traffic advisory is you get on your display the bearing and relative height of your traffic. That means in your display, in your computer screen, you will get to see that the other traffic is at 20 degree to your left. Is it straight in front of you? Is it 20 degree to your right? So it tells you about your bearing. Okay, from at what direction, at what relative bearing is that traffic from you. Second information that is displayed is relative height. Let's say you are at 1000 feet flying and the other traffic is flying at 1200 feet directly in front of you. So the information, if this is your aircraft and the other traffic is over here and you are going like this and the other traffic is at 1200 feet and you are at 1000 feet. So the relative height between your aircraft and that aircraft or that traffic will be plus 200. So this information plus 200, if it's 100 feet below you, minus 100, so on and so forth, relative height will be displayed to you. So this is the thing about traffic advisory, caution area. Okay. Next thing, to make matters worse, if this traffic continues, okay, continues on its flight path and approaches your flight at a very close distance and enters this red color bubble. Okay, when it enters this red color bubble, now it is very close to you. The height at which is relative to you is very close. So this bubble will be called warning area. Okay, now the situation has become more unsafe, or there might be a possibility of threat. So this bubble will be called warning area. And warning area, the traffic is 15 to 20 seconds away from you approximately. 15 to 20 seconds away from you. So only that much window of time you have to react or respond to the other traffic coming towards you. Okay. And when traffic enters this bubble of warning area, the TCAS system will give you another advisory, which is resolution advisory. Resolution advisory. Now what is resolution advisory? Initially, you get a traffic advisory, just the traffic information. Okay, in resolution means a solution. Now, when there was traffic advisory, you got information. Now it is up to you what you do with that information. You can pass that information to ATC and obtain a new clearance, a new flight level, a new cruising altitude, or you can change your direction so that you go away from that other traffic. But if you don't do any of this and that intruder aircraft or the other traffic comes towards you, now it's a dangerous situation. You have to immediately respond to it. Okay, there should be a solution. So the system is designed in such a way that it tells you whether to climb or whether to descend. It gives you one instruction to climb or to increase your climb rate if you're already climbing, to descend or to increase your descent rate if you're already descending, in order to evade or in order to avoid other traffic. So in a resolution advisory, you get instruction. So either you get climb, increase climb, or descend, increase your descent. Okay, so these four instructions, one instruction you will get by the TCAS system, and you will only get this instruction in terms of vertical plane. In terms of vertical plane. So that means either climb or descend. You will not be asked by TCAS to turn right, to turn left. Okay, you won't get instructions in a horizontal plane. You will get it in vertical plane only. So these are the two outputs given by TCAS system. First, traffic advisory and information. Next is resolution advisory, which is you have to follow. When you get a resolution advisory, you have to follow that resolution advisory, and you have to divert from ATC instruction. In that particular case, that is an exception. And when you are clear of traffic, when you are in a safe situation, you can come back to your original level or original altitude that is given by or that was given by ATC. And when you come back, you can inform ATC of what happened, that you had to follow a resolution advisory. That's why you had to divert, you had to, deviate from the assigned cruising altitude or from the assigned flight level. Because as per rules of the air, you cannot deviate from the assigned cruising altitude or flight level on your own without obtaining ATC clearance or instruction, right? But this resolution advisory is a particular exception because the safety is paramount. Now we have two types of TCAS, TCAS 1 and TCAS 2. In TCAS 1 system, aircraft that have TCAS 1 will only get traffic advisory. So TCAS 1 only gives traffic advisory. TCAS 2 will give you traffic advisory. It's a development, technological development, and it will also give you resolution advisory. Okay, so how long will a TCAS 1 give a warning for? So TCAS 1 will give a traffic advisory for 40 seconds. So for 40 seconds, you will continuously be given that display information on your screen. Okay, you will keep getting that warning. of traffic advisory. So that is the case about TCAS 1. Now let's go to next question, question number 7. There I will do one detailed lecture on TCAS system, and I will put that in radio navigation playlist. So do subscribe to this channel so that you get a suitable notification whenever I put that video in the playlist, and you can watch that video. Along with that, I will also solve back questions from this chapter from Oxford, and I will put that into a separate playlist of solved questions radio navigation. And the third playlist of Keith and Williams, we will also solve all the questions from Keith and Williams TCAS chapter, and that video I will upload in that Keith and Williams radio navigation playlist. So when you subscribe to this channel, you will keep getting those notifications whenever I post that video in the channel. Next question. Deviation from true airspeed in the flight plan. True airspeed that we have given in the flight plan to the ATC is to be reported to ATC. By how much true airspeed must deviate? So now if you say that you are going to fly at your cruising altitude at a true airspeed of 500 knots. So you have to maintain that 500 knots that you have told ATC in the flight plan. Now there is certain range given to you within which you can deviate from that 500 knots. But if you deviate from that 500 knots beyond a particular range limit, you will have to report that to ATC. Okay, so there is, by rules of the air, they have given a particular limit beyond which or less than which your true airspeed should not deviate or should not increase or decrease, and that value is 5%. Okay, so your true airspeed must remain within 5% of it. Okay, it should not increase beyond that 5% of the true airspeed or less than that by 5%. So this value you have to remember, and this question often gets asked in exams. Last question. The lift generation depends on what factors? Now the lift that wing generates depends on two factors: angle of attack and the shape of the wing, which is both A and B. Okay, as your angle of attack increases, the angle between your chord line and the relative airflow, or the angle between chord line and your flight path, okay, is as that angle increases, the lift generation capacity of your wing increases. And also the shape of the wing. If the wing has a great camber, that is the curvature, okay, that will also intensify low pressure above it, and as a result you will get more lift generation. And when angle of attack increases up to a certain point, that is critical angle of attack, again the low pressure above your wing surface intensifies, and that increases the lift generation capacity of your wing. So both shape and angle of attack depends influence the lift generation of